Section 7.2 is the ambiguous case of the law of signs. Before we start, let's talk about the case we've already studied. What did we study last time? Which case?
The oblique triangle.
Case 1. All of these deal with oblique triangles.
Okay.
But it was case 1. And what did we know about case 1? For case 1, we were always given
Two angles.
two angles
and one side.
and one side. And that's just your basic law of signs case. When we do that, we solve for the third angle by doing 180 minus the other 2, and then we use law of signs twice to find the missing two sides if we need them. Remember that? Okay, so case 2 is what we call the ambiguous case. The reason it's called ambiguous is there's a possibility that you could get no solution at all, you could get one triangle just like you do with case 1, or that you could get two different triangles. And we'll talk about in a minute why that could be true. In this case, you are given two sides and the angle that is not between them. You know two sides and one angle that is not between them. So that's what we're going to be studying today. So as our textbook points out, if we are given the lengths of two sides and the angle opposite one of them, okay, not between them, opposite one of them, then 0, 1, or 2 such triangles may exist. That's where the ambiguity lies. Maybe it's not possible at all. Maybe it'll work out the exact same way it did before, and we'll just have one unique triangle. Or there may be two completely different triangles that could work. Now from a math standpoint, it kind of stinks because we have to take the time to investigate that and figure out what's going on. But from an engineering or architectural standpoint, it's nice to have those options sometimes. You know, it's nice to find yourself in a position where you have two different ways you could build something. But then again, it's really bad to find yourself in a position where you couldn't build it at all. Does that make sense? So this is like the headache of the case, but when it does work out, there are two ways that you could build that triangle. That's really nice as far as engineering and architecture are concerned. So one more time, in the ambiguous case, because it's going to be important, more important than you recognize any of the other cases, okay? You have to remember that you are given two sides and an angle opposite one of those sides, but not the angle in between. Side angle side is a law of cosines problem, and we'll talk about that in section 7.3. So let's take a look first at this example, and you can see that we've already pointed out that when we finish, we're going to realize that there is no such triangle to meet this criteria. So this is an impossible situation. So we want to figure out how do we determine that. If we have a triangle ABC, and we know that angle B is 55 degrees and 40 minutes, we know that side little b is 8.94 meters, and side little a is 25.1 meters. That's all we know. So we need to get a diagram of that going. So let's let this be A. B. C. Here's what we're looking at so far. We know that capital B is 5540. We know that side little b is 8.94. And that's in meters. And side little a, which has to be the one opposite of capital A, is 25.1 meters. And we want to figure out what the missing A, C, and little c are. Take a look at what we were given. How many sides were we given? We were given two sides and one angle. And that angle is not between them. It is opposite of side B, right? Okay, so we know that's the big ambiguous case once we draw it and look at it and see what we were given. It's going to be important that you recognize that. Now, what we do know is that 25.1 divided by the sine of A has to equal 8.94 8.94 divided by the sine of 5540. So let me write that down and see if you agree. 25.1 divided by the sine of capital A must equal 8.94 meters divided by the sine of 5540. Where did I get that? Law of sines. According to the law of sines, that has to be true. Okay? So let's just kind of start working that out. We cross multiply. We have 8.94 times the sine of A is equal to 25.1 times the sine of 5540 and that would mean that the sine of A must equal whatever 25.1 times the sine of 55 degrees and 40 minutes divided by 8.94 meters is. That's what our sine has to be. So everybody pause for a second, get your calculator, and I want you to tell me what 25.1 times the sine of 5540 divided by 8.94 is. Okay, what did we find for sine of A? Now this is an A, this is what sine of A equals. Sine of A equals 8.91. Okay. Is that what everybody got for the sine of A? Does anybody see a problem with that before we even go any further? Yeah, I have a problem with that. Sine can only be between what two numbers?
-1 and 1.
-1 and 1. There's something wrong here. We cannot have a situation where the sine ratio is more than 1 or less than -1. That just can't happen, okay? In a triangle, we can't have negative numbers at all, so that would be even, well, that's not true. The cosine of a triangle could be. I have to think about that for a minute. Could that be true? No, that couldn't be true. In a triangle, we cannot have any values that are negative, okay? Not even the sines or the cosines. Now in a unit circle we can, but when we're dealing with revolutions and not triangles, we deal with different directions and things like that, so sometimes you do produce negative values, but not in a triangle. So a lot of people would know right here that this is an impossible situation just based on that sine ratio. But if you don't catch it from there and you keep solving, how do we release this angle here?
Sine inverse.
The inverse sine or second sine. So you would go through and you would second sine that. And that's how you would solve for that angle if it existed. But when you do that, your calculator knows better. What does it say? It says domain error. That's impossible. So what we've found here is this is an impossible situation. These ratios will not allow us to design a triangle with that criteria. So it's impossible. And so what we say then is that this triangle does not exist. So for us that's really good because we don't have to work the problem out anymore. But if we were architects or engineers and we were trying to explain to people why we could not build something that way, then they would be very unhappy, right? So sometimes out in the real world like that, you have to explain to some little old lady that you cannot, no matter what she wants, build her cat house that way. And you don't want to upset the little old lady. So it's a bad situation to find yourself in. So that's one of the things that can happen with the ambiguous case of the law of sines. That never happens with case 1. If you know two angles and one side, you can always build a triangle to do that. But if you know two sides and the angle opposite one of them, there comes a time when you will find yourself in an impossible situation, and you have to start learning to recognize it. Any questions about example 1? So how are we going to answer that?
Does not exist.
Does not exist, right. We're not going to put no solution, we're not going to put undefined, we're not going to put error, we're going to write does not exist. Got it?